Hi guys, this is Group 6 and it's our pleasure to present you guys with our final project, Tetris AI Challenge. So let's start with the purpose of this project. Since we want to add an AI competition mode to the classic game which is Tetris, um, during the investigation phase, we found lots of available AI approaches. For example, the heuristic-based AI or DQN learning, which is a quite famous reinforcement learning framework. And so we want to evaluate different AI approaches performance in the production environment. What are the pros and cons of using different methods? For example, here we have heuristic-based AI and also deep learning, and we can deploy them on the kernel function or on the server side or on the client side, like the local machine of the user. So what are the pros and cons of different combinations of these methods? That's what we want to investigate into. So here's today's outline. We will start with our project's overview, which includes the techniques we used and a little bit about the implementation details. And then we would have a go through a live demo. And finally comes the conclusion and analysis of this project. So let's start with the project overview. Just like other full stack project, it has a front end and also a back end. Besides, we have the AI model, which is separate from the previous two. And in this three section, we will talk about what techniques we used and why we choose that technique, and also a little bit more about the implementation details. So here's the front end. We use the combination of React and Next.js as our front end library and the framework. We use Tailwind CSS to style our components, and also use Zoostan to manage our state, a game board state. And for the backend, we hosted our static web page on the Firebase, and AWS EC2 are our server which we deploy our model onto. And here we have two main AI approach, which is the first one would be the heuristic based AI, and the second one is DQN learning. And here's a brief introduction or illustration of it. DQN mainly consists of two main components. One is environment and the other one is an agent. The agent would observe the environment and take action, and based on the action agent take, the environment will give them back rewards, and also which is also the response. And based on the response, the agent would update its neural network's parameters using back propagation or gradient descent. And so let's first talk about the heuristic based AI. So the overall idea is to compute a score for each possible move. So here possible move refers to, for example, a move right or rotate. And the score is calculated mainly based on four main criteria: the lines completed, the overall height, the bumpiness, and the host. And here's the formula for calculating this score. And here the ABCD are or coefficients, which is manually in this project they are manually selected and tested. And this approach is fully embedded in the front-end JS code, thus the response time is relatively low. And the second approach is deep learning. Compared to heuristic-based artificial AI method, they both use the same four criteria to calculate whether an action is good or not. But the difference is that in this method, uh, it is not calculated by a linear function. It is actually calculated by a neural network, which can actually represent a more complex and nonlinear function. And the parameters are trained by interacting with the environment using gradient descent. So let's have a quick demo. So here's the visualized training process of our DQN. And this is our game, and you can access using this link. And we're not going to the sprint and the infinite mode. We can just go to the AI challenge mode, and on the left hand side you can play around it, and on the right hand side it's actually controlled by the artificial intelligence. And the current mode is the current level is medium, and you can set it to hard or easy, and it's totally up to you. And this is just a quick demo. So let's uh, go back to the analysis and conclusion section. Here are several metrics to evaluate our model, which is response time, scalability, maintainability, performance, and I would just pick up several to illustrate. So for the response time, things uh, for heuristic based method, the response time is relatively low because we know the code is purely embedded in the front end using JS. And as for the deep Q learning deployed on the server, the response time is around zero point 0.3 seconds, and cloud function based can take a lot longer because due to the code start of the cloud function, which means that after sometimes no one's calling that function, the resources would be released, and that's the main reason behind the long response time. And as for the performance, I think both three have a relatively good performance, but compared with DQN, heuristic based is a little bit worse. But I think that's totally enough to beat a non-player. And so here comes our conclusion. For heuristic-based AI, it's easy and fast to deploy its pure front-end JS. It's embedded purely in the front end, and it doesn't have a fantastic performance, but like I said before, it can be an amateur player, and it's suitable for the demo or prototype, and we can later switch to an AI model like the deep Q learning model, which have a better accuracy and a little longer response time. But I think it's worth it, and yeah, because the accuracy is actually a lot higher, and we know with growing users, we can easily scale up because we can buy more servers or buy a larger throughput of our cloud function. And I think that's all. And here's the bibliography and also the reference of this project. And so thanks for listening.